So in chapter 5, we're going to take a look at what's called systems of equations. So this is going to feel more like algebra, more like solving an equation, less like what we did last week. Okay, so the first thing is, what are systems? Well, we're going to write down what a system is, but we're going to spend most of this term solving systems of equations. Okay, probably, definitely this week, the next week, and I think the week after that. Okay, so we'll spend a lot of time on this topic. There's different ways that you can solve these kinds of problems. What way do you think we're going to solve, or what method do you think we're going to use to solve them today?
Linear equations.
Yep, how do you think we're going to try to solve them today? By doing, we're going to solve systems of linear equations by graphing. Yep, so that's one method that you can use to solve a system, graphing. So we're going to look at graphing today. We're going to look at a different way to do it tomorrow. And then the third way, we're not going to do this week. Okay, we're going to look at that next week. Okay, so what is a system? So on your guided notes, it says and then you have a blank. You want to fill in what's in bold. Okay. A system of linear equations is a set, and then you have the rest of it already written. It's a set of two or more equations, and they have to use the same variables. And the goal when you're solving a system isn't just to find one answer. You have to find two answers. Okay? Now it says that a system can have two or more. We don't do or more. Okay, we're going to stick with just two. But three, solving for three letters at the same time, that's pretty common. But two is what we're going to stick with. Right, so let's see if we can come up with a system of linear equations. So like we did in the warm-up, can somebody give me an equation that has an x in it and has a y in it? You can have the y be by itself, or you can have the y not be by itself. You can do it any way you want. But I just need someone to give me an equation that has an x and a y in it. And you can put numbers in front of the x and the y if you want. And it's going to have an equal sign too.
4x plus 3y
4x plus 3y
equals 12.
Perfect. That's a linear equation. Yep. 4x plus 3y equals 12. I could get y by itself if I really wanted to. All right. Now to be a system, you have to have a second. What would be another equation?
Y equals 2x plus 3.
Y equals 2x plus 3. Perfect. So both of those are equations with x and y. One of them has the y by itself. I like that one. That would be easy to graph. The top one doesn't have y by itself, but I could fix it. Now the way we would solve it is we would graph the top one, we'd graph the bottom one, and once we do that, we'd have two lines. And the goal was to figure out where they cross. But that's an example of what we call a system. You have to solve for the x, and you have to solve for the y. So the goal is to find two answers. Two answers. Okay. Any question on that? Now, think about if you're finding two answers. Okay? One of them is an x, one of them is a y. What's something that we write in math a lot that has an x in it, and then a comma, and then a y in it? There's a name for it. Yeah? Yeah?
Coordinate.
A coordinate. That's exactly what you're finding. Okay? You're finding a coordinate when you're solving a system of equations. Okay? You can also call a coordinate an ordered pair. Okay, so in the next blank where it says a solution of a system of linear equations, so you're going to write down what's in bold. And then the rest of it you already have. So a solution to one of these kinds of problems is a coordinate, or an ordered pair. So a lot of times what we have to do is once we find a coordinate, or once we find an ordered pair that we think is the solution, we have to check it. And the way we check that something is a solution is you take the two numbers that you get, one for x, one for y, and you plug them back into the original problem, and you see if they work. So that's where this part of the warm-up is going to come in. Okay, when you're checking your answer, take the two numbers that you got, and you plug them back in. All right, so then the last bullet, it says to determine if a ordered pair is a solution to a system. You're going to write down what's in bold. You're going to plug the ordered pair. Again, that's what you have to figure out. You've got to figure out the numbers into each equation. You're going to have two. You have to plug them into each equation. And you're going to see if you get true statements. All right, so let me make up a system. I'm going to make up an ordered pair. And let's see if it works. All right, since I'm going to do it in my head, I'm not going to make up a really complicated ordered pair or problem. It's going to be pretty simple. All right, so let's say I gave you the equation x plus y equals 5. And then I gave you the equation 2x minus y equals 3. Okay, that's an ordered pair. It's two different equations. They each have an x and a y. Now let's say you solved it and you came up with this. Let's say you came up with so you came up with 2, 3. Somehow you thought that was the answer. Okay. To check that that's the answer, we're going to plug it back in and see if it works. Which number here is the x?
2.
The 2. And which number is the 3? Or what letter is the 3?
1.
That's the y. Okay. Let's plug that into the top one and see if it works. So let's just check it off to the side. What are we filling in for x?
2.
2. And what are we filling in for y? 3. I'm going to put a question mark. And what's it supposed to equal?
5.
It's supposed to equal 5. Okay, let's check. What's 2 plus 3? 5. Does 5 equal 5?
Mm-hmm.
Yeah, so that's true. So that means the coordinate works in the top one, but it has to work in the bottom one, okay, as well. Let's check that one. Okay. What am I going to fill in for x here? Yeah, it's the same one that we did the first time. So we're going to fill in 2. What are we going to fill in for y?
3.
So minus 3. And if it comes out to 3, then we're good. If it doesn't, it means that answer is wrong. Even though it worked in the top, it's got to work in the bottom. What's 2 times 2?
4.
So 4 minus 3 equals 3. And what's 4 minus 3?
1.
Okay, does 1 equal 3?
No.
No. So what that means is that coordinate right here, that's not the answer. That's not the answer to the problem. So if that's the answer that we got, at this point we have to go back and do the problem again because something's wrong. Is there any question on that? Okay, so when you find an answer, it has to work in both. What if you check it in the top one and it doesn't work? Do you need to check the bottom one?
No.
No, because it has to work in both. So if you check it in the top one and it doesn't work, well, you can just say doesn't work. You don't even have to check the bottom one. But if it works in the top one, then you got to keep going. You're not done because you got to check that it works in the bottom. All right, let's try another one of those. Okay, it says tell whether the ordered pair is a solution to the system of equations. Okay, so you've got the coordinate 2, 5. The top equation is x plus y equals 7. And the bottom equation is 2x minus 3y equals negative 11. Okay, so you're going to fill in 2 for x, 5 for y, and check it in both equations. We'll call this equation 1 and equation 2. Okay, so take a minute and see if you can figure out if 2, 5 works in both of the equations. If it does, then 2, 5 is a solution. If it doesn't, then 2, 5 is not a solution. If it's not a solution, you don't have to find what is the solution. I haven't shown you how to do that yet. You just have to write yes or no. Okay, so let's take a look at it. You can set up your work however you want. I just went like this. That made sense to me. If you don't have enough room to do it this way, you can check it however you want to check it. All right. So what number are we filling in for x?
2.
2. All right. Let's start with the first one. So we're going to fill in 2. And then what number are we filling in for y? 5. And I put a question mark here because we don't know if it's going to work. That's what we're checking. I'm just copying down what's on the other side. And then what's 2 plus 5? So I get 7 equals 7. Is that true?
Yes.
Yeah. As long as you get the same number on each side, then it works. Okay, so we figured out what works. Can I just write yes? Am I all set?
You do the second one.
I need to check the second one. You can't say it works if you've only checked one of them. You've got to check the second one. All right, so now we've got 2 times, and what am I filling in for x again?
2.
Yep, it's always the same number you did the first time. For x, minus 3. And what are we filling in for y?
5.
5. And then the question, will that come out to negative 11? Okay. What's 2 times 2? So that's 4. Minus, what's 3 times 5? So we get negative 15. Okay. And what's 4 minus 15? That is negative 11. Does negative 11 equal negative 11? Yep, get the same number on both sides, so that's good. So now tell whether this ordered pair is a solution. Is it a solution, yes or no?
Yes.
Yes, it is. Yep. And it's the only solution. You couldn't find 2 other numbers that would work. It's impossible. Because if we draw each one of these, what's the shape when we draw these as a graph? What do they look like? Yes? No, they don't look like a dot when we draw each one. What do they look like? Like an X shape, right? They're going to be 2 lines. And when you draw 2 lines, how many different places can they cross if the slopes are different? They can only cross once. They can only cross one time. That's why there is only one pair of numbers that would ever work in both of them. And in this case, 2, 5 are the numbers that work. Let's try another one. Right. So now under B, try that one. Negative 2, 0 is your point. And the 2 equations are y equals negative 2x minus 4 and y equals negative x plus 4. If this was a problem that said solve, and they didn't give you this, and you had to figure that out, that's perfect because y is by itself in both. Now we could graph it and do it very easily. But you don't have to graph it because they gave you the answer. Possibly. They want you to check if what they gave you is correct. All right, so check that one, and then call one of us over, and we'll. So let's take a look at this one. All right, so off to the side, I'm gonna check it. Okay, and what are we filling in for y this time?
0.
0 equals -2. That's going to stay right where it is. And what are we filling in for x?
-2.
-2. And then -4. Okay, so I'm going to simplify it off to the side. So I've got 0 on the left. What's -2 times -2? 4. Negative times a negative is positive, so it's 4. Oops. So 4, and I still have the -4. And we get 0 on the left. And what's 4 minus 4?
0.
0. So did that work in the top one? Yes, because we got the same number on both sides. So can I just say, yes, it works? What else do I need to do? Got to check the bottom. Okay, so what am I filling in for y?
0.
Yep, so I'm going to fill in a 0 there. I have this negative. And what number am I filling in for x? -2. So be careful. There's a negative in front because that was in the problem. And there's a negative with the 2 because that was what was up above. Okay, so we have -2, then +4. What's the opposite of -2? +2. And what's 2 plus 4? 6. So does 0 equal 6? No. So these two numbers worked in the top one, didn't work in the bottom one. So is it a solution to the entire thing? No. Nope, doesn't work. Any question on that one? All right, let's do C together. Okay, so the point they're giving us this time is 1, 4. And here's the two equations. Y equals 3x plus 1. Y equals -x plus 5. It doesn't matter which one you check first. If you want to check the bottom one first, you can. If you want to check the top one first, you just got to check them both. Okay, so let's check it. Right, in the top one, well, and the bottom one. But what number are we filling in for y?
1.
Y is going to be the second number.
Would be 4.
It's going to be 4. So 4 equals, we've got the 3. Leave room for what you need to fill in for x. And you have the plus 1. And what number are we filling in for x? 1. Okay, so let's simplify that and see what we get. On the left-hand side, there's nothing to simplify. Just a 4. On the right-hand side, what's 3 times 1? 3 plus 1.
4.
4. Does 4 equal 4? Yeah, we got the same number. So we know that it works in the top one. Let's check the bottom. Okay. In the bottom, what are we filling in for y? 4. Same thing we did in the top. Equals, you've got the minus, leave room for what you're going to plug in for x, and then put plus 5. Okay. And what are we filling in for x in the bottom? 1. Same thing we filled in for x in the top. Okay. Is there anything I can do to simplify the left-hand side? No, it's just the number 4. But on the right, we've got negative 1 plus 5. What's negative 1 plus 5?
4.
4. Okay. Does 4 equal 4? Yeah. So these two numbers worked in the top. They worked in the bottom. So is it a solution to the whole system? Yes or no?
Yes.
Yes, it is. Okay, yeah. Yep, just sign out. Okay, so that's called checking. It's basically checking your answer. They give you something that could work, and you have to check if it does. And we found that some of the time it did work, some of the time it didn't. Now, the next step is you figuring out these numbers yourself, okay, instead of me giving them to you, and that's what we're going to look at now. Okay, how do you figure out the 1 and the 4? All right, so in the first, I think it was the first one and the last one that we just did, they worked. What did we say we're going to be looking for? We're going to be drawing 2 lines, and we're going to look for where the 2 lines do what? Where they intersect, exactly. So on the back of your guided notes, actually you don't have to write that part in, but that's the idea of what we're doing. Now, I'm pretty sure we used these last week, right? So what's really nice about these calculators is I can type in anything I want. Right? I can hit graph. The calculator will automatically draw pictures for me for what I did. And it can automatically tell me where those lines cross. And the nice part about the calculator being able to tell me is, look what I just got for answers. Okay, there's an answer for x and there's an answer for y. Did I get nice numbers for x and y?
No.
No. This isn't a problem that I would ever have you guys do by hand, because there's no way you're going to graph something by hand and ever be able to figure out the answer is 2.9375. How are you going to do that with a piece of graph paper? You can't. That's where the calculator comes in handy. It can find answers even if they are decimals. For us, I'm going to make sure that this number and that number usually don't have any decimals. Okay? So you'll get answers like 2.5 or -2.0. Okay? No decimals in the answers. Okay. So how do we solve a system by graphing? Okay, there's going to be 3 steps. So on your guided notes, where it says step 1, the first thing you want to write in is graph each equation in slope-intercept form. So that means if they give you an equation that's not y equals mx plus b, you need to fix it. You need to get the y by itself. And that's what we practiced in the second problem in the lab. Just a reminder, which letter there is your slope? M. And which letter is the y-intercept?
B.
The B. Yep. So you're going to graph each equation. And when I say estimate the point of intersection, I'm hoping it's going to be pretty easy for you to figure out. It's not going to be a decimal. Okay? If you get a decimal, or it doesn't look like they cross in a nice spot, chances are you graphed it wrong. Okay. And then once we have what we think the answer is, what do you think we have to do now?
Check.
We have to check it. Exactly. How do you check it? That's exactly what we just did in the last 3 problems. Take what you got for x and y, plug them back into the originals, and then see if it works. How many original equations are we always going to have? 2. When you plug your answers back in, which one of the equations does it have to work in? The top one or the bottom one?
Both.
Both. Has to work in both. Exactly. Good. All right. So I know the grids, they're kind of small. On Edge Elastic, it's going to be bigger because you can zoom in and make the graph as big as you want by making your screen zoomed in. All right. Does everybody have steps 1, 2, and 3? All right. So let's try example 2a. Okay, it says solve the system by graphing. We want the equations to be in y equals mx plus b. Is equation 1 in y equals mx plus b?
Yes.
Yes, it is. Perfect. Is equation 2 in y equals mx plus b?
Yes.
Yep, perfect. So both of those are as good as they can be to graph. Okay, they're ready to graph. In example 2b, I guess they're also in y equals mx plus b. All right, so let's start with this one. Let's write down the slope and the y-intercept. What's the slope of the first one? 1 over 1. Yep. And what's the y-intercept? 1. All right. Now let's do the m and the b here. What's the slope of number 2 as a fraction?
3 over 1.
So, yeah, I'm just going to do it like this. 3 over 1.
-5.
And -5. Okay, what I'll do is I'm going to do this one in red. I'll do the bottom one in blue. Okay, so what's the y-intercept of number 1? The red one.
1.
1. So where am I going to put a dot to represent that?
1 up.
Yep, 1 up. And now from that dot, this tells me which way to go to get to another point. So from the red dot, which way do I go?
1 up and 1 to the right.
Exactly, 1 up and 1 to the right.
Nobody has to do all those dots.
No, you don't have to do that many. I'm just doing a bunch of them so I can get a pretty accurate picture. But yeah, as long as you got a couple dots, and on Edge Elastic, you only have to do 2, and it's going to draw the line perfectly. It's just because it's so big on the board, it's hard for me to draw it accurately. And you need to draw pretty accurate. If you don't draw accurately with like a ruler, this method doesn't work. So you've got to have graph paper, and you've got to have something straight like your ID, or to be able to make a straight line. Okay, so that looks pretty good. As good as I can do. Okay, so there's our first one. Now let's do the second one. Okay, what's the y-intercept of my second line?
-5.
Yep, and I told you I was going to do this one in red, so let me just make it red. Okay. So -5. So down 1, 2, 3, 4, down 5 from the origin. And then how do I get to the next point on the line? Which way do I go?
3 up and 1 to the right.
3 up and 1 to the right. So 1, 2, 3. What do you think? Are these lines going to cross somewhere?
No. Actually, yeah.
Yeah. as long as the slopes are different, they're going to cross. What kind of lines have the same slope? Does anyone remember? Parallel. So we're not going to be looking at parallel lines here. That's a special situation. That'll be next week. Okay, so we're going to have lines that cross. They will not be parallel. So 3 up, right 1, 3 up, right 1. Look at what just happened. I think I already found where they cross before I even finished drawing the line. Okay, so I'll just put one more dot, but I can already see where they cross. Okay, so let's make our line. I did not do as well that time. Let's fix that. So that looks pretty good. Okay, that's the blue one. All right, let me zoom in so you guys can see that a little better. And where does it look like the lines cross?
At 3.
Yep, so I'd say 1, 2, 3.
Yeah, 3.
3 and
4.
5.
3.
3 and 5.
4 and 4.
Yeah, I would say 3 right and 4 up. 1, 2, 3, 4.
Is it 4?
Yeah. So 3 right, 4 up. How would I write that as a coordinate?
3 and 4.
3, 4. Okay. Now let's, just like we did in the first two problems, let's check and see if we plug that in and it works. Okay. The first equation is y equals x plus 1. Okay. I don't have enough room to check it up there, so I'm going to check it down here. Oops. All right. So y equals x plus 1. Okay. What number do we think is the y?
3. Oh, wait, no. 4.
4. Okay. X, y. So we think 4 is the y. And what number do we think is the x?
3.
3. All right, so we get 4 equals, what's 3 plus 1?
4.
4. So what do we know about that point then? It works where?
And the first equation.
In the first equation. Okay, all we know is that it works in the first equation. We still need to make sure that it what? Eli, what do we still have to make sure of? All we know is it works in the first equation.
Oh, we need to match in the second one.
We got to make sure it works in the second equation. Okay, so y equals 3x minus 5. All right, let's try. I'm going to do that one over here. Okay, so that's the second equation. Okay, again, what do we think the y is supposed to be?
4.
4. Okay, so let's check. What do we think the x is supposed to be?
3.
3. I don't know why it jumps down like that. It's been doing that a lot. What's 3 times 3?
6.
That's 3 times 2.
9.
9. And what's 9 minus 5?
4.
4. So what do we know about this point now?
That it matches.
Well, yeah, it works. Yeah, the numbers match up. It works in the second equation. So it worked in the first one, and it worked in the second one. So what does that mean?
Then it's a solution.
It's the solution. And it's the only solution. There are no other numbers that you could find that would work in both. So 3, 4 is exactly the answer we would want to write down. Okay. Any question on that one? Okay. Eric, can you put your hand away from me?
Yeah.
Thank you. Okay. Let's try one more. This time I'm not going to check it, but let's just at least try to find what we think the answer is. Okay, so solve the system by graph. Okay, let's write down the M and the B. And let's write down the M and the B. Okay, what's the slope in equation 1? Yeah.
2x.
So equation 1, so we're looking at the top one, and remember slope is just a number.
-1.
-1. Yep.
Over 1.
Yeah, I'm going to write it as over 1 just to make it a fraction. And what's the y-intercept?
4.
4. Okay. How about equation 2? What's the slope?
2, 1.
And what's the y-intercept?
8, -8.
-8. So that's a pretty low number. Hopefully it doesn't go off the graph where they intersect. Otherwise we're gonna have a problem. Okay. So let's start with the first one. My y-intercept is 4. Where would a y-intercept of 4 be on the graph?
4 up.
4 up. 1, 2, 3. There's your y-intercept. And using the slope, how do I get to another point on line 1? Which way do I go?
You go 2 up and 1 to the right.
So we're still looking at equation 1.
You go 1 down and 1 to the right.
1 down and 1 to the right. Yeah. Down 1, right. Okay, so I made a bunch of dots. Again, you don't need that many. I'm just trying to make a really, really good picture. That looks pretty good. Okay, so there's my first one. Now, what's my y-intercept for my second graph?
-8.
-8. So where do I go to do a y-intercept of -8?
You go 8 down.
8 down. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. And now using the slope, how do I get to the next point on the line?
You go 2 up and 1 to the right.
2 up and 1 to the right. And I'm going to hope if I do that enough times, I just land on the black line. If I don't, then we're going to have a decimal in the answer. So let's try it. 2 to the right, 1 up. 2 to the right, 1 up. Look at what just happened. I landed right on the line. So by doing that, I pretty much already know what the answer is going to be. Okay, so we should check it. We're not going to check this one. But where does it look like those two lines cross each other?
Around 5.
0, 4.
4.
All right, so how are we going to write the chord?
0. No, 4 and 0.
4, 0. 4 to the right, and then there's no up or down. So the answer is 4, 0. If you check that, I'm pretty sure it would work. Okay. Okay, but I'm not going to check this one. Any question on that one? Okay, so those are the kind of problems where you have to figure out the answer yourself, but at least they give you the two equations to use. In this one, they don't even give you the equations. So the first thing you have to do is figure out what are the equations I need to use, then graph them, then see where they cross. Okay. Do you guys already have that example printed Okay, just make sure everything's the same. Small candles are $4, large candles are $6. You spend $144, and you sell 4 more large than small. Okay. So, how many equations do we have to come up with when we write a system? Yep.
2.
Yep, we need 2. The first one is usually going to be the first sentence in the equation. So somehow we have to turn what's underlined in blue into an equation. And then you sell 4 more large than small. That's going to be the second equation. What are the 2 letters that we've been using a lot?
X and Y.
Yeah, so why don't we just stick with X and Y? We're figuring out how many of each type of candle we sell. What are the 2 types of candles that we have for sale?
Large and small.
Large and small. So do you want X to be the number of large
Yeah.
or the number of small?
Number of large, I guess.
Okay, so X is going to be the number of large. And that means Y is going to represent the number of
Small.
small. Okay. Okay, let's start with that second sentence. You can start with the first one, but I'm going to start with the second one. You sell 4 more large candles than you do small candles. Let me reword that a little differently, and I think it'll be easier to see what that means. So, the number of large candles is, how much is it? 4 more? Yeah, 4 more. Number of large candles is 4 more than the number of small candles. That's the second sentence. I just reworded it a little bit, but it says exactly the same thing. The number of large candles is 4 more than the number of small. Okay. So let's start with this part. How are we representing the number of large candles? We picked a letter to represent that.
X.
X is. What does is mean?
Equals.
Equals. The number of large candles is. How are we going to represent what I just underlined?
4.
Is more. More than. What operation in math means more than?
Plus.
Plus. Number of small candles. How are we representing number of small candles?
Y.
Y. There you go. That is your first equation. The number of large candles is 4 more than the number of small. So we've essentially taken care of this. Don't cross it out because you still need to be able to read it in your notes. But that information is used up. So we don't need that anymore. We need to take the top one and make it an equation. All right, so let's think about that. How many types of candles are we selling?
2.
2. What are the 2 types?
Large and small.
Large and small. So here's kind of the idea. We know that the money from the small candles plus the money we make from the large candles equals something. So if we take all the money we made from selling small candles and all the money we made from selling large candles, how much money did we make?
144.
We made $144 from all the candles we sold. We sold 2 types of candles.
I can find out that story.
Alright. So now we're going to figure out money from small candles. How much is each small candle?
$4.
$4. And what if I said to you, you sold 5 of them? What would you do with the 4 and the 5 to figure out how much money you made? Multiply them. So you take the price per candle times how many you sold. Well, the price of the small candle is 4. Or is that the large candle?
Small.
Oh, that's the small. Okay. So the small candle is $4. And how many small candles did we sell?
We don't know.
We don't know, but how did we represent it?
Why?
Why? Yeah.
I mean, can't you just divide it by 2? Divide 144 by 2?
No, we can't divide it by 2.
Why?
Yeah, because we don't know that we. Why would we divide by 2?
I mean, you can do divide by 2, then take out. You said you sold 4 more large ones. How many you take out 24 from them? You would get 72, then 72. You would get 96.
All right. Well, let's see if we get the same answer. How much does each large candle sell for?
$6.
$6 times how many large candles did we sell?
We don't know.
We don't know, but how did we represent it?
X.
X. How would you write 4 times y?
4y.
Yeah, just 4y. How would you write 6 times x?
6x.
6x. And then what goes on the other side?
144.
144. That is your second equation. Okay. That number is a little bit bigger than I want to really deal with, 144 for this problem. So if you can just come up with the 2 equations, I'm happy with that. Okay. Now, once you have the 2 equations, the next step would be take each equation, draw them, and see where they cross. Okay. But that was the hard part, coming up with the 2 equations. But that's where I'm going to stop for this one. I'll make sure that when we do one on the test, the numbers come out a little bit smaller. Okay, so homework tonight is the worksheet on 5.1. Okay, so remember that's on Schoology. When you get to the word problem, if the numbers come out really, really big, we're going to hold off on doing it. But if the numbers are small enough, we'll try to do it in class together. Okay, but at least see in the homework if you can get this far, come up with the 2 equations. I think there's only one word problem on the homework. It's the very last question.